We are continuing through chapter 12, which is our introduction to physics. And last time we learned about how to add display objects to the physics engine as physics bodies and what happens to them, and also how to manipulate characteristics of the physics body, like its bounciness, its friction, and its density. We also learned about two different types of physics bodies. The dynamic physics bodies, which is the one that will drop, say, under the force of gravity, and then the static physics objects, physics bodies, which will stay put. And so in the example we had last time, we created a ground as a static physics body, which was just a rectangle. And then we had a simple white ball that was a dynamic physics body that we dropped and bounced on the ground. So we are going to forge ahead today with using images instead of plain display shapes. So I have a variety of options in the chapter resources you could download. The screenshot in the keynote is of what's called the magic ball. Just as a little bit of a preview, let me say that the magic ball is actually going to be harder than you might think, or it presents a challenge that you might not expect. Okay, so we're going to create a simple physics app, essentially to duplicate what was in the screenshot in the keynote. So we need the image. That's kind of the star. So I'm going to load an image display object, and I'm going to grab this magic ball 88 by 88, which is in the chapter downloads. I'm going to move it, and I'm going to add a rectangle for the ground and put it down by the ground. And I'll fill it with something that looks, we did grass last time, so how about something soilish? I don't know, something that looks kind of like dirt. And then I'm going to head to the physics palette. I'm going to set up physics, and then I'm going to select the magic ball and say add body. And then I'm going to select the ground and say add body. But for the ground, I'm going to change its physics body from dynamic to static. So I'm going to click the button that says dynamic and make it say static. So this is a physics app. Physics will start, gravity will take hold of the ball, pulling it down into the ground, and it should then bounce off the ground. We know it won't bounce very well, so I'm going to head to the magic ball's physics body and crank up its bounce a bit. It doesn't really matter exactly what. I'm going to save this. Again, I've already got this folder for chapter 12, so I'm going to call it drop magic ball 88. You'll see the ball dropping, and then it bounces off to the side. Let me do it again. It clearly is hitting the ground and then bouncing off at an angle, which doesn't entirely make sense, right? When we did the plain white ball, the circle, it bounced up and down over and over again. It didn't jump off to the side. So this is odd, but at the same time, I did warn you that the magic ball is going to present a little bit of a challenge. First off, this magic ball has been scaled to be quite small, so it's really supposed to be used as a small ball. So we could go back to the magic ball display object and shrink it a bit. So that's not going to help us though, really. The issue is the physics shape. What we see when we look at that magic ball is we see a circle, but let me zoom in now. What the computer sees, I don't know how good the zoom image is, but if you're following along, try to zoom into that magic ball and look at the outline. It's not smooth at all, right? I mean, I'm looking at the transition between that outer black line and then the alpha see-through part, and it's very pixelated. It's very jagged because this is a very low resolution version of the magic ball. And so why is that an issue? Well, when the physics engine sees that, by default, it would actually treat this as a as a rectangle. So let's actually switch it to a rectangle just so that you see all the variations. So I'm going to head to the physics body for the image and switch this physics shape to use rectangle, and then save it, see what we get. So the rectangle version works pretty well. It did stop it from ricocheting kind of off to the side or off at an angle, and that's because the rectangular physics shape is perfect. It's just sized at the outer edge of the image. So there's no jaggedness in that at all. But it's also not great because although we can get away with this simplification in an app that just has one bouncing ball, it's not going to work in a more complex physics app. So what are our options then? Well, the physics shape can be a rectangle. It can be a circle, which is what we used last time. And the circle will also work perfectly. It could be this third option, which is a generated image outline. And so this is kind of the magic in Solar 2D is you can ask it, you can say, look at the image and figure out what the outline should be. And then the fourth option is you can use the polygon editor, which is manual, and enter in XY coordinates that define the outline of the object. For anything rectangular, obviously you just leave it at the default rectangle. If what you're using is a perfect circle, then you can use circle. But if it's an image, you either have to decide, is it close to circular, in which case maybe I want to use a circle. Is it close to a rectangle, in which maybe I want to use a rectangle, or is it something more complex? The trouble is Solar 2D has a limited ability to generate this automatic outline. It tries to do it, but it's limited in terms of the number of points it can use. Right now I'm forgetting, I'll add it to the video as a pop-up or something. Right now I can't remember what the limit is, but it's way less than you would expect. It's limited to just a handful of XY coordinates to outline the shape. So that becomes difficult when the shape is like we just saw in that magic ball. If the shape is super jagged like that, then Solar 2D is going to try to add points which follow that jagged outline, and then it's also going to run out of points that it can use, and the outline shape will end up being badly misdrawn. This is what will get us into trouble, and the first thing to do is to switch our draw mode. So anytime anything's happening in your physics app that doesn't make sense, like a ball that should drop and bounce vertically instead bouncing off to the side, anything like that, you want to stop and say, I need to see what's going on. I need to see what the physics engine is seeing. So we do that by changing the draw mode. To change the draw mode, we get into the setup physics script object, and the buttons over here are to start and stop physics, and then also to change the draw mode. If you hit the draw mode button, it'll go from normal to hybrid, and hybrid's what we want. Hybrid will show us the image, but make it half see-through, and it'll overlay it with what the physics engine is seeing as the physics shape. You would expect it to be a circle that matched up with the image. The thing is, it's probably not going to be. So let me save this and just see where we're at. Let me relaunch it. Yeah. So this is hard to see because it's happening fairly quickly. So I'm going to slow things down. Let's drop gravity quite a bit. See what that does for us. There we go. Much smaller. Okay, so I hope you guys can see what's going on. I'll keep refreshing it while I talk so that you can. So I'm sure you're having a good look. You can see the magic ball is still there, and it still looks like a circle. But you see, overlaying it is a half circle, and actually kind of a jagged half circle. That is what the physics shape is. That's what the physics engine is seeing. So even though you and I see the magic ball, the physics engine sees this half circle. If it was rotated a little bit, it could actually be even weirder, and half of it could sink into the ground. Let's think about then what we might do about this. I think we're all in agreement that this is bad. We want the physics body to match the display objects that the user sees, at least as close as possible. So heading back over to the add body for the image, let's look again at our options. Well, I told you rectangle would work fine, so let's change it to rectangle and see what that looks like. So now you can see the rectangle outline, and you can see the ball bouncing perfectly because that's also what a bouncing cube would do in a 2D physics engine. So actually to the user this would look right, but if it was a more complex world, then you'd have those corners sticking out from the ball that would interact and cause the ball to act like a square instead of a circle. And in fact, so square is not a good option. Circle's a great option. So if we hit it, use circle, and then hit the update button, Drawn a Code will look up the radius and set it so that you don't have to go back and look. Now this is pretty good. Let's go back to generated image outline though. So this is what gives us the crazy half circle. But there's a setting in there, I don't know if you saw it, texel coarseness. So you can actually tweak the function Solar 2D uses to generate that outline. So we can add some coarseness to it and see if that'll help it out. So adding 2 didn't do anything. Let's try some more. Hey, there we go. So that's a texel coarseness of 4. And you can see it's almost made it all the way around. So let's up it as a guess. Now, see, that didn't improve it at all. So let's try 5, see if that gets us anything better. So I mean, the idea is you can kind of tune in the coarseness in some ways to get a better representation of the shape. In this case, this magic ball is so coarse around the outside that the Solar 2D function that tries to figure this out is just not able to make a good outline. In this case, it's lucky because the magic ball is a circle, and a circular physics shape is an option, so it's perfectly fine to use the circle, and that's what you should use. Certainly images, because of that jaggedness in the outline, or the potential for that jaggedness in the outline, can really trip the function up. Images that have straight edges as outlines, this technique tends to work perfectly on. So this is what we just did. We played around with different options. So bottom line is, if physics is not working the way you think it's working, stuff is bouncing oddly, ricocheting oddly, then turn on hybrid draw mode. And as soon as you turn on hybrid draw mode and run the app again, you should see one or more of your shapes probably don't look right. The thing that happened to me, just as I was learning it many years ago, I set up a kind of a simple ramp or a wedge, and I dropped the ball on it thinking that it was going to ricochet off to the side, and instead it didn't. It bounced on the triangle and ended up resting just like in the screenshot here. So this is a screenshot of this app after all the bouncing is done, and you can see the magic ball's just hanging there kind of in midair. It doesn't make sense. The physics engine was using a rectangular physics shape, therefore to the physics engine it was not a ramp or a wedge, it was just another rectangular box. So the ball bounced on it like it would bounce on a square box, a rectangular box, and then when it was done bouncing it just sat on top of the box. To the user, that's not what we saw. We see the ball hovering, in midair, not ricocheting like we expected, and then ending up hovering, in midair. The solution for the ramp would be, if it was a basic polygon, a triangle, then we'd use the polygon shape that Drawn a Code will match up for you. So let's actually do that and get our first wedge. Okay, so in this first example, I actually do just use a polygon. Let's just give it a little bit more width. And I'm going to put it right here. I'm going to put the ball above it. If I ran it right now, pause and think, what do I think is going to happen? So I'm running it. Here we go. So the ball goes right through the ramp, the wedge. It goes right through the wedge because we didn't add the wedge as a physics body to the physics engine. So from the physics engine standpoint, it does not exist. So I'm going to select the wedge. I'm going to move to the physics palette and say add body. And then I'm also going to switch it to static because I don't want it to drop under the force of gravity. So now it is static. Let's save that, see what we get. This is going to work. I have high confidence. There we go. I'll rerun it a couple times, but the ball is still moving very slowly because I got rid of a chunk of gravity. So this is more like dropping a ball on the moon or something. All right, let's try to do something a little more fun. We can change it so that the ball only drops when the user taps something. So I've got a couple versions of bonus games in the downloads where you can tap to drop these balls. And I've got this one which is tap to drop with wedges. So let's just code it, see how tough it is. Since I already have this running and I already have a wedge in here, and it's already static, so it'll stay in place. Let me add a couple more of these wedges. And then add the tap to drop last. And I have a target for it to knock over as well. I need to add 8 and 9 as physics bodies as well. So I'm going to select it, hit add body, change it to static. And then for the third one, I'm going to select it. I'm going to hit add body, and I'm going to change it to static. That should get us something that looks like the start of some kind of a game. I still have the bounce set way high on the ball, which is why it's acting like that. It did kind of roll a little funky, so let's head back to the balls, add body, and I'm going to decrease the bounce a bit, a slightly less aggressive bounce, and I'm going to increase the friction to make sure it's going to roll correctly. That's a little better. Yeah. Okay. So we want to add tap to drop, and then so the question is, what do you want to tap? So let's add something to tap. In the screenshot in the keynote, you'll see that I have an arrow, which is a polygon. So I'm going to add a polygon, and then I'm going to edit the shape and make it the down arrow. Hit update shape, hit done. Let's add a bit of color to it. All right. So I want to add tap to drop. Let's just think about it. I want the user to be able to tap the arrow, and then when they do that, it'll drop a magic ball. So I need to add the tap listener to this polygon. So I'm going to select the polygon, choose add listener, and select tap. And then what I want is the code necessary to create the ball and add it to the physics engine. I want those script objects inside of the tap handler. So let's find them in the stack. Here's the image. So I'm going to move it into the tap handler by selecting it and choosing move image into function. There's only one function, so that's got to be it. And then the add body for the image is object 4. I'm going to do the same thing. I'm going to select object 4 in the stack. I'm going to hit the button move resource into function, and I'm going to move it into the tap handler. If you're watching the stack, you'll have seen object 1 and object 4 move into the tap handler. What we have left outside is the ground, I've done a bad job of naming stuff, so let me take a second here and name these. Hopefully you are doing this. So this polygon is the top wedge. This polygon's the middle. And this polygon's the bottom. Okay, so now the stack reads a little bit more nicely, right? Here's my ground, the add body for the ground. Here's the top wedge, the middle wedge, and the bottom wedge, and then the 3 add bodies for each of those. Here's the last polygon, which is the arrow. So I'll say the tap arrow. And now it shows up a little bit more descriptively. And then inside the tap handler, I've got the magic ball and the code that adds the magic ball to the physics engine to cause it to drop. All right, let's test it. Save it and test it. So I'm not in as big a hurry this time because first off, you'll notice, well, nothing dropped. On all the other examples so far, as soon as we started the app, the ball dropped and I had to rush over to the simulator so that we caught it. Now nothing dropped. So nothing dropped because the ball does not exist yet. It has not been created because you have not tapped the arrow. So let's tap the arrow. There's the arrow tap. And now you see there's the ball dropping. Cool thing is you can keep tapping. This may now seem a little bit slow, but you are starting to see that this interaction between physics bodies. Those balls hit each other. They're hitting the ramp. If the physics shape was not really close to perfect, they would not hit each other and bounce off of each other in the way you would expect. You would get odd behavior if your physics shapes didn't match what the user saw on screen. Let me turn off the hybrid draw mode to get us back to something that looks a little better. I'm also going to move the ball up a little bit more, and I'm going to put physics back to normal at 9.8. All right, this should get us something that acts more like you might expect. Balls drop much quicker. There we go. Interactions look good. Rolling looks good. Everything looks pretty good. So the last step was something to knock over, a little target. So let's add, what I intended this to look like was sort of like a domino that you were knocking over. So I just made a little rectangle and put it on the ground. I added it as a physics body. And then, well, let's see what happens. So the thing here is, if the balls aren't dense enough and aren't moving fast enough, they won't knock that over. If they're super dense, they'll blast right through it, which is pretty much what they're doing. So you can certainly give the rectangle a little more density. You could take away some density from the magic ball and then see what happens on screen. That still knocks it over. You'd have to play with the density quite a bit more to make the balls, well, if you wanted them to be light air-filled balls of some kind, they're at this point they're still way too dense. And you could dramatically increase the density on this to make it a little more resistant to being knocked over. We also talked about friction, but luckily the friction has worked pretty well for us. If you have the friction set too low, it'll look really strange. So let's do that. I'm going to hit the add body for the magic ball. I'm going to just drop friction down to nothing. Let's see what that does. So this is now a perfectly smooth magic ball. Oh, yeah. So I don't know if you notice or not, but it's hitting stuff and deflecting off of it, but it's not rotating. There wasn't any friction for the surfaces to grab onto to get the magic ball to start turning. So instead it slides kind of sideways. Don't know if you can tell in the in the zoom if the resolution's high enough or not, but let me increase the size of the magic ball. That might help. And I have to update the physics shape. All right, see if if you can see the kind of the oddness of it. You can kind of see it's just moving. They're just moving sideways. They're not turning like you would expect. It's really kind of odd. In this case, that oddity has nothing to do with the physics shape. The physics shape is perfect. That oddity has to do with there being no friction at all. So you also want to remember to play around with the friction to get the effect on screen that you want to have. Yeah, we're going to pick up next time on essentially stacking stuff. So we're going to use a timer and stack up a bunch of boxes, and then we're going to use the wedge and the ball, and we're going to drop balls, hit the wedge, see if we can knock over the stack. That's where I wanted to get to today. Tap to drop, playing around with the physics, playing around with the friction to get the rotation to work like you want it to. I hope it's getting more fun. We will finish up this chapter 12 next time, and then move on to collisions, getting stuff to happen when collisions occur.